Finding tangent lines is something that's very important in math and can be pretty difficult, actually. The only curve that it's easy to find tangent line to is a circle, because it just happens to be this rule that the tangent line is always perpendicular to the radius. So if this is 0, 0, 3, 4, this radius has a slope of 4/3, and that makes the slope of the tangent line -3/4. But let's look at another fairly simple curve, which is parabola, y = x squared, and one of the points on it is the point 3,9. And just like circles have tangent lines, parabolas have tangent lines also. And every point would have a different tangent line. This one would have negative slope. This one would have slightly less negative slope. I want to go over how 3 different ways of finding the slope of a tangent line of a parabola, specifically this parabola, and at this point. The answer is going to end up being 6, just spoiler alert. But we're going to see 3 different ways of doing that. The first method I'm going to call the discriminant equals 0 method. And the way this works is we say, okay, this line here, its equation, all we know is that it's got a point there. So I'll use point slope form to say y - 9 equals m times x - 3. And I could even change that to y equals mx minus 3m plus 9. So it's got these m's in it. Now another thing I know about this parabola and this line is that the intersection, there's only one intersection point. So if I were to take the equation y = x squared and the equation y = mx, I'll say plus -3m plus 9. If I take that as a system of equations and I go to try to find the intersection, I'll get some sort of quadratic equation. If I substitute x squared in for this y here, I end up with this equation. I should probably put x squared on the left. And then if I move everything over to one side, it would be minus mx, and I would get plus 3m. Now, for any value of m, when I intersect a parabola with a line, depending on what the value of m is, I might get no intersections, I might get 2 intersections, or I can get 1 intersection point. What would cause me to get 1 intersection point would be if the discriminant b squared minus 4ac, if b squared minus 4ac equals 0, then there'll be just one solution to this equation. So I'm actually going to make that equation. B is negative m, so this becomes negative m squared. See, a is 1. That's b. And this thing here is c. So b squared minus 4, a is 1, c is 3m minus 9 equals 0. This turns into m squared minus 12m plus 36 equals 0. That thing factors to m minus 6 squared equals 0, m minus 6 equals 0, and m equals 6. And what that means is that if the slope of this line is 6, this line will only touch this parabola at that one point. Method number 2. It's called Descartes Method. This is the hardest of the methods. It's actually based on a similar idea. Descartes' method is to try to imagine putting a circle if you imagine we try to put, this parabola is like a big cup, and we try to fit a circle so that it would just kind of sit there in such a way that the circle hits the same point here, the tangent point. Now, we don't know much about that circle. We don't know anything about it, really. For now, we'll call the center of the circle 0, comma V. I also don't know what the radius of the circle is. I'm just going to call it R for now. Believe it or not, from these two unknown pieces of information, we are going to be able to work out what R and V are. And here's how that works. So the circle's center is 0V, so we can say that the circle's equation is x squared plus y minus v squared equals r squared. The parabola, we already know, is y equals x squared. And we have a lot of variables here: x, y, v, r. There's a third equation that's going to be useful. If I draw in this little right triangle here, that little right triangle has a hypotenuse of r, and the legs, well, in this case, this bottom leg is just 3, and this little small, I'll make it green, that leg is v minus 9, because this here is 9, and the entire line segment going up to the center would be v. So notice how these both have r squares in them. I can get rid of one variable by just setting the two equations equal to each other. They each equal r squared. I also have y equals x squared, so I can take this x squared and replace it with a y. So now I have y plus y minus r squared equals 9 plus v minus 9 squared. This is going to simplify to, I'll do these steps. (81 plus 9 is 90. I just realized that this was a v. Makes this a v also. So I get y plus y squared minus 2vy plus v squared is v squared minus 18v plus 90. If I bring everything over to one side, and here's a part that people struggle with, y minus 2vy, if you factor out the y, you get 1 minus 2v. And everything else comes over, the 18v and the 90. So now we have just a y and a v, and it still seems like too many variables, but here comes the trick. We want there to just be one answer. We want to find the v value that would make this circle intersect the parabola in just one. Actually, it's in 2 different points, but there's only one y value for it. So that's our discriminant equals 0 trick. B is 1 minus 2v, so b squared is 1 minus 2v squared minus 4. A is just 1, and c is 18v minus 90. And that becomes 1 minus 4v plus 4v squared minus 72v plus 360. And when we combine our like terms, we end up with the equation 4v squared minus 76v plus 361 equals 0. This thing actually factors. That always seems to happen in these questions. So v equals 19 over 2. Well, that's not the answer yet. 19 over 2 is just the 19 over 2 is the y-intercept of that circle. Well, that means that the radius of the circle, which is going to be perpendicular to the tangent line, we can find the slope of that, 3, 9, and 19 over 2. So this is 0, 19 over 2. So the slope of the radius, the 3, 9 is also on the circle. So it's 9 minus 19 over 2 over 3 minus 0, which is 19 over 2 actually over 3, which is 19. Oops. Sorry, 9 minus 19 over 2. 9 is the same thing as 18 over 2. So 18 over 2 minus 19 over 2 is negative 1/2 divided by 3 is negative 1/6. And since the tangent line is perpendicular to the radius, it will be the negative reciprocal, which would be 6. That's called Descartes Method, and it's not the greatest method because it's so long. The quickest method is actually called Fermat's method. This one only takes a few seconds. The trick is to pick a point to the right of 3, 9. How much to the right? Call it h. 3 plus h, and since the parabola is y equals x squared, 3 plus h squared. And if I connect these 2 points, I get a secant line. It hits 2 points on the parabola. So we're just going to find the slope of the secant line, which is not the same thing as the tangent line. So the slope is y2 minus y1 over x2 minus x1, which is 9 plus 6h plus h squared minus 9. These 3's cancel out over h. These 9's cancel out. Factor out an h and get 6 plus h. Cancel out the h and we get 6 plus h. So this means that the slope of the secant line is 6 plus whatever h is. Now, the closer h is to 0, the closer these 2 points are, the more this thing is like a tangent line. So here's where we get a little bit non-rigorous. We say as h goes to 0, 6 plus h goes to 6. And 6 is the answer. So this was 3 different ways of finding that the tangent line, the slope of the tangent line to the parabola y equals x squared at the point 3, 9 is 6.